Now, before we can go into discussing sampling distributions, it's important that we know the fundamental counting principle, okay? Or at least we know how to identify possible number of outcomes. So let's proceed. Now, the fundamental counting principle states that if there are x ways to do one thing and y ways to do another thing, then there are x times y ways to do both. So for example, we have here Carmela is about to unlock her cell phone, but she forgot the passcode. She only remembers that the four-digit code contains the numbers 1, 8, 9, 0, and 2. Now, how many possible passcodes are there if no repetition is allowed? So, again, the passcode is a four-digit code, okay? And it's important to take note that no repetition is allowed. So, let's try to represent our codes into circles. Now, take note that what we are looking for in this problem is not the specific code, but what we're looking for is the number of possible passcodes, given the possible digits of the passcode and the number of digits that the passcode have. So here we have a four-digit code, that's why we have here four circles. Now, for the first digit, how many choices do we have? So we have 1, 8, 9, 0, and 2. We have 5 choices for the first digit. It can be any number out of those 5 numbers, right? Now, since no repetition is allowed, we cannot repeat a digit. So here, one digit will be taken away. So for the second digit, we only have 4 choices. And then for the third, we only have 3. And for the last one, we only have 2 choices. Now, following the fundamental counting principle, we multiply all these numbers together and we'll get 5 times 4 times 3 times 2, that is 120. So if there are no repetition, there are 120 possible passcodes of Carmela's cell phone. Okay? Alright, now let's go to question B. How many possible passcodes are there if repetition is allowed? So here we still have 4-digit code, so let's represent our digits into circles. So we have okay. Now, for the first digit, how many possible options do we have? Okay, we can have 1, 8, 9, 0, and 2. So we have 5 possible options for the first digit. Now for the second digit, repetition is allowed. So meaning to say whatever number that we have here in the first digit can also be the number in the second digit. So that means for our second digit, we still have 5 number of options, 5 choices that can be possible value for our second digit. So the second digit, we have 5 possible options. Same with the third, because again, repetition is allowed. And same with the fourth digit. So what we have here is 5 times 5 times 5. And multiplying, we have 625. So without repetition, with repetition, we have 625 possible passcodes of Carmela's cell phone. Okay, so just keep in mind the fundamental counting principle, and you can apply that when you make or when you construct sampling distributions already. That's all, and see you in our next video.